Hello and welcome, and in this video we will learn how to create custom clouds of any shape we want, how to customize them using different techniques inside of Volume VOPs. As you can see, if I just tweak a little bit, we can actually have our cloud looking pretty good just from the simple geometry that is indeed our squab. So if you want to learn, watch the video and let's have fun creating clouds. Welcome to this second episode of getting started with volumes and volume VOPs inside of Houdini. And in this one, we finally get to actually create our own cloud. So let's jump straight into it and start with geometry. And we can do any cloud we want, any shape we want. So for this one, again, I'll just start with squab. And I will do VDB from polygons. As you can see, Shift Enter, we have this thing going on, and we can do it with density and we can do it with distance, but obviously since we're working with clouds, I think density will be just fine. So voxel size 001, I think it will work well. And of course we do the volume visualize. As you can see, volume visualization, Shift Enter. I think we can do the density scale something like 10, so we can actually see our volume a little bit better. So before we actually start working with our volume VOPs, I want to make sure that you know that if you hover your cursor over the viewport and press here or press D key, you can get to the texture tab, and there is the 3D textures where you can limit or disable the limiting as of the resolution of your clouds. You can enable it and disable it if you think that you actually have more resolution in your cloud than you actually see. However, be careful, because sometimes when you disable this limit resolution, the actual rotation of the viewport, it becomes like 1 FPS or sometimes even low. It just chugs along like this, tick, 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 tick. It's very annoying to work with. So if you think you want to preview the resolution, you can disable this. If you don't and you want to retain the actual speed of the viewport, you can enable it back. Of course, when you render, it doesn't really matter because, well, it renders in full resolution. So that's all right. Now, let's get back to our clouds. As you remember, you can actually create some clouds, cloud noise, all that kind of stuff. But how do we actually go about creating our own one? So if you have seen the attributes introductory series inside of Houdini, you pretty much know that you can work with vertices, points, or edges, primitives, whatever. And actually you can also work with volumes. So if you start typing VVO, like volume VOP, and drop it here, we indeed can now work, and we'll go to our volume VOP, and you can see that density goes back to density, and well, that's the result. So basically we do nothing with our density, and well, we have something going on. In fact, I can just make this to be visualized and do the multiply by constant, drop it here, and now we can multiply the density here. So you will see that indeed our density increases. Or if I multiply it by 0.1, you'll see that we faintly see our thing. So basically it does what it says. So essentially, you can see that indeed we can manipulate our volumes as if, well, any other VOPs, really. So what can we do? Of course, you might imagine that we can use any sort of noise, and you will be right. And of course, let's do, I don't know, anti-alias noise. Or no, actually, you know what? Let's do the turbulent noise. I like it more. I like it better. So we do the density. Let's try first multiplying the density by some sort of noise. Of course, we need to have the position of the noise. Here it is. And now we can multiply the noise result by the density. And we have this going on. Let me do the volume visualization here. So this already gives us, well, something, right? We can tweak it. We can increase the amplitude, we can increase or decrease the frequency, so we can do something with it. However, you can see that it's not exactly, moving our smoke around, moving our cloud and density around. That's because literally what we do is we remain the density as it's in our voxels in place, and we just multiply it by some sort of, this alligator noise thing. Is there a better way? Of course there is. That was a trick question. Now, what we can do is actually sample. You will see there is volume sample node. It's actually a little bit tricky to use. So we have this volume sample file, right, as it says here. And what we can do is input is not the file, but instead it will be the first input. So in our case, our first input here is, well, our VDB, right? Now, the first input here, the file name, we connect our inputs to the file name. Okay, you follow? And then we connect the volume value here, and the position is here. Okay, well, I know it's kind of weird, so let's do this once again. I'll hold Y to actually delete all the connections. So what we had previously is density going to density. You know, all is fair because nothing is happening. Okay, so we get this volume sample. We get the input from the first input, which in our case is the actual VDB, right? The position that it is sampling we get from the P as in position. And the result will be our density, right? As you can see, nothing happens again. However, the magic starts happening when we actually start adding, here we are, adding the position to our noise, and this position will be sampled to our volume. And look what's happening, voila. We already have a lot of volume displacement, right? And if we decrease the amplitude to, let's say, 1 to something more manageable, you will see that indeed we have a very interesting result that can be used to create some sort of cloud going forward, right? Let's pre-visualize with our volume visualization thing. You will see that it actually works a little bit, you know, kind of weird, because here we can see that we have our squab not actually being taken into consideration by the displacement of the volume. Here it's pretty much destroyed. So how do we mitigate this anomaly or discrepancy of the volume getting applied to our geometry? If you remember from our previous videos, we can actually force any negative number to become a positive number using a node that's called absolute. In this case, the turbulent noise in the alligator noise, many other noises, including Voronoi noise and Worley noise and other noises sometimes, they do not take into consideration negative values of our position. As you can see, it kind of applies things in a very weird way. So, however, if we absolute the position, as in negative positions become positive positions, you will see the difference immediately. It is getting applied everywhere. In my case, I want to do this. All right, okay. So again, without absolute, with absolute. As you can see, it's pretty different. So if we increase the frequency, we can see that we can have kind of bubbly spherical geometry, which kind of looks pretty cool if I'm being honest. You can of course do anything you want with these noises. When we will be creating some sort of rock formations, we actually will subtract from distance 2, distance 1, and the result we will input here. As you can see, that we will be using to create our rock formations. But more on that later. In this case, all I want to do is actually use the turbulent noise connected through the absolute and add it to our position so it gets sampled, and in this case we can increase or decrease any number of things here, and of course if we don't like this we can offset it however we want. You can switch from 1D noise to a 3D noise to get a little bit more variation. Alligator to, for example, original Perlin, sparse convolution, whichever you prefer. It does not really matter. In this case, the only thing that matters is your kind of personal preference. As per usual, the turbulence kind of dictates the amount of differences that's happening per permutation of the noise, and the roughness is the difference between those permutations. I explained it a little bit more in depth in the previous videos of the VOPs. You can watch those to learn more. So basically, when you find sort of like the wispiness that you want, you can actually increase the volume, increase the amplitude more than one. It displaces a lot. And of course, you can tweak it to make it a little bit more or less wispy and or defined however you want. So you will see that we do not really go from the VDB here and we displace our noise, but it kind of stays in the same place. And if you remember, we talked about the VDBs, that they're not being calculated outside the voxels that are actually being taken into the account. Of course, it's better for memory conservation and for computation, make it faster, of course. But sometimes you need more voxels than you actually are with from the get-go. And we can do this by VDB activate. If I drop it here, well, first let's check out what it does. And we will do the expand, and we will expand the voxels, right? So we can expand it. As you can see, something is going on with our cage here. So if I expand the voxels here, and I go to our volume VOP, and I can showcase, if I increase the expand volumes, you will see that our noise starts taking more of the surrounding volume around our geometry, as opposed to what it was. Okay, so let me enable the volume visualization. That's what we had before. And if we expand the voxels, you can see it takes into consideration much more, well, voxel information. So that's really useful. Of course, you can tweak the distance here. Whoops, be careful because, it can be slow, right? So anyway, let's get back to our volume VOP. And so just so we are on the same page, when you activate the voxels, you create much more computation, because the voxels that were before activation, we had, let's say, 1.5 million voxels. Now it's 2.5, right? So it was 1.5, now it's 2.5, right? So be careful with this. It can really bring your PC down. So get back to our volume VOPs. Now we can tweak it a little bit more. So I can maybe increase the turbulence to 7. And as you can see, we already have something interesting. Maybe increase the roughness, maybe actually decrease the roughness. So this will be our main forms, okay? So naturally, we can also add more noises. For example, more turbulent noise. We get the position. Again, here is the position, the absolute position here. However, this one will be just adding a little bit of wispiness here and there. And here we are. I added some sort of noise. Let's make it 3D noise. Let's make the amplitude much less. However, increase the roughness quite a bit. And maybe turbulence makes 7 or something like that. And as you can see that without, if I just disable this, we had this kind of like big shapes going on. As you can see, roughness was 0.5, the frequency was 0.5. However, here frequency is 1, roughness is 0.8. This is those little things that increase this wispiness just a little bit. Of course, we can increase the frequency again a little bit. And naturally, what we can do is you will see again that we have this problem that this looks like a thing that hasn't been affected by anything. So we can actually offset our noise a little bit. Or indeed, we can make the negative amplitude so it starts to carve out these elements here and add them a little bit here. So again, if you don't like how this looks, we can change the alligator noise, for example, to zero-centered Perlin noise and have this thing going on, which again looks pretty interesting. Again, play with the offset. So, okay, so we tweaked it so it kind of looks pretty interesting. The final thing that we can do is we can get our geometry and we can scatter some spheres. Here it is. So we can get the geometry scatter, copy to points. Target points will be our scatter points. And the thing that we want is, well, those spheres. As you can see, well, that kind of looks weird. What I want to do now is I will decrease the total amount to something like, I don't know, 18, something like that. I will decrease its relaxed iterations, and I will actually squash the sphere, changing the radius like to, I don't know, 0.2 maybe, right? And now what we can do is we can hold down the Alt key, kind of like this, select those two, hold the Alt key, it will merge automatically. And now when I get the VDB from polygons, I get this thing. And of course, when I activate, it expands the volumes, expands the voxels, and the volume VOP will now create this kind of thing. In fact, I don't think I like it that much, so maybe 0.1 volume visualization, and this is what we get. I think it's time to tweak. So as you can see, the offset in the y-axis, it actually seems to be giving us the strongest differences in the results. So I think I'll tweak it a little bit in the sped up way. There is nothing, special going on about this right now. It's all about tweaking the way you want it to look. Okay, I think we finally broke up this central piece. So now what I want to do is increase the resolution of this by quite a bit. And remember, when we increase the resolution here, we actually have to increase the radius of the activated VDBs in our VDB activation, because the smaller the voxels become, the higher the resolution they have, the more expansion the voxels will need to actually do what we want. So that's the results I got. We can now try and actually render this. And in fact, I will save it first, and now we'll go to stage. I press import all, and now we can do the dome lights. Dome lights can be anything you want. If you don't have anything, we can just go to Houdini Pick HDRI. It has the noon. That will work just fine for us. And of course, we drop material first. So we get the material library, go inside, we go to para preview, drop it here on Geo1. As you can see, it automatically created the assigned material. And now we get to Karma, get to XPU, and start the Karma XPU. Now, for this to work, for Karma XPU to actually evaluate our cloud as it should be, we have to have it as a VDB. For example, if you have here written volume, be sure to convert it to VDB first. In our case, obviously, we were working with VDBs, so there's nothing special about it. Now, in this one, we can start increasing the scale or decreasing the scale or whatnot. As you can see, when I decrease the scale, I can see that I absolutely do not like these blobs. So what I'm going to do is I'm going to go back and preview how it's being scattered. Of course, to change the how they are scattered, I can increase or decrease the amount, or I can just tweak the global seed. I think this might look fine. Let me just decrease the resolution a little bit so it calculates a bit faster. Go to activate, go to the volume VOP. Let's look at what we have. So in this case, I think this looks kind of nice. And it renders as pretty much the clouds I wanted it to be. So again, if we get to our material library, we can tweak the density scale, of course. We can tweak the smoke color just a little bit to make it ever so slightly warmer tone. And of course the absorption color, if we make it like this, as you can see, this will get an immediate result. But if we just apply just a little bit of this, the result that we want. Now, of course, if you don't like this dome light, you can actually disable it, and of course we can now create an area light, and if I aim camera here and press Control area light, you will see that it will indeed create the area light. And if I disable this look, you will see that I can look. I will move the area light here, of course, make it much bigger, kind of like this. I think will be fine. Let's see. And I think we can have another area light just around here, have it looking down. It should be nice enough. Okay, so this is uniform scale, let's say 4. This uniform scale, again 4. However, the actual exposure, I think this is a little bit too bright. This one is a little bit too bright as well, maybe. So in that case, I think we can make this a warm one, and the area light 2 we can make kind of like a cold one. So it has a nice gradient going through, and we have a really good looking variation going through our. So of course, if we now replace our squab, for example, with our piggy, kind of like this, I think we can now have a much different cloud. And of course we will have to go back to our volume VOP, and we will have to start tweaking our offsets, so it kind of takes care of this kind of blobby pattern right there. But you know, it's nothing super serious. Fix the blobbiness pretty effectively, have a somewhat different looking cloud in no time. As you can see, the original Perlin noise in our lower, bigger effect of noise looks pretty amazing. It really does look like a cloud. It's well, basically destroys the shapes in a very spectacular shape and form. And of course, if you make it a little bit less rough, it doesn't have that much wisps, but it doesn't look as sharp. So after tweaking a little bit, I found that our big displacement noise works pretty well with the original Perlin noise. So this is how you create clouds, and obviously you can make a cloud of any shape you want, as you might imagine. If you learned something, press the like button. If you have ideas, suggestions, don't hesitate to leave a comment. And if you don't want to miss the next videos, that will include animating the clouds and making a looped animation of those clouds, and exporting VDBs to Blender and possibly even to Unreal Engine. Don't forget to subscribe, and you know, don't miss the next videos. Hopefully I will see you in the next video. Thanks for watching. See you later. Have a nice day, and bye bye.